Hello everyone, I am Radha Kumari Pani, Assistant Professor at VIT. So last class we have discussed about the phase transformation, which is the part of metallurgical engineering. So today we are going to discuss about the thermodynamics and kinetics, which is the important part in material science. First, what do you mean by thermodynamics? See, thermodynamics, it is the combination of two words, thermo and dynamics. Thermo means heat. Okay, heat means temperature. And dynamics means motion. It is the nothing but motion of heat. Okay, how the heat is given to the system, how it is respond to the heat. Okay, so in today's class, we'll be focused about the thermodynamics, and I'm sure you must have learned about the thermodynamics in your +2 classes, but it is the most important topics in material science. We have to understand what are the law of thermodynamics and what are the parameters of thermodynamics. Okay, so second, first we're going to introduce about small we're taking some experiments, okay, to better understand about the what are the thermodynamics, how it is respond. First, by taking we'll taking one aluminium rod. This is one aluminium rod, and we are going to heat about 500 degrees Celsius. Okay, about 500 degrees Celsius. We are going to heat aluminium rod. First, it will some extend its length. See, first it is in this shape. After heating, it will going to expand like some length. It will going to expand. Why? Why it will expand? It can be because of two reasons. First, due to what? The vibration of atoms. The atoms, aluminium rod. Okay, aluminium atoms are there in the rod. Aluminium atoms are there. By some heating, the aluminium atom can go vibration. Okay, so first reason can be due to, by the vibration of atom, it can expand, or the second reason, the concentration of vacancy. Okay, first it is a solid material. One solid material is there, and all the aluminium atoms are packed, close packed. If you are heating the aluminium rod, then some atoms may go to bulk to surface area. Okay, like this is the solid material, and some aluminium atoms are closely packed. Okay, if we are heating, then some aluminium metal can go from bulk to surface area. So here in the bulk, some vacancy may create. Okay, so by creating some vacancy, it may expand. Okay, it can be two reasons. One is vibration of atom, and the second reason is the concentration of vacancies. Okay, again we'll take some second experiment to understand the what are the thermodynamics potential means. In the second example, we are taking some elastomer. This is elastomer or rubber, we can say. First, by some stretching, the elastomer may expand. By putting some weight here, the elastomer is extended up to this length, let x. Again, if we are hitting the elastomer, then the elastomer may contract to previous position, like to this position. This contraction may be vibration of atoms, or maybe the second reason of the previous experiment, that is what? A concentration of vacancy. So why this is happened? Why after heating the expanded strength is contracting to previous length? Why? It can be two reasons, like some potential is there, that is can be gives free energy or entropy. It is the thermodynamic parameter gives free energy, or entropy means some randomness. Okay, some perturbation we can say. So these are the terms which is the reason behind after heating why it is stretching, why it is contracting. So in today's class mainly we will be focusing only the thermodynamics parameters, what are the parameters are there, or what is the potential. Okay, now let some we'll going to see some mechanical equilibrium. Let some box is there, like this is the rectangular box, and first it is in the position configuration, let's see one. Okay, and by shifting its configuration, we'll see how its stability is changing according to the configuration. Let in the y-axis we are taking the potential energy, which is directly proportional to the height of center of gravity. Okay, here the potential energy PE is directly proportional to the height of center of gravity of rectangular box. Let in the C1 position it is the metastable state A. It is the potential energy is this much. Okay. Again, if you are tilting the rectangular box to this side, to right side, to the C2 configuration, it is the most unstable state. Why? Because the potential energy in B configuration is high. We can see this is the potential energy of B configuration, because here in the C2 configuration we can see the rectangular box, the center of gravity is shifting to this position. So the height of center of gravity is more, the potential energy is more, so the stability is less and the instability is more. Then after shifting the tilt the rectangular box to C2 to C3 position, and this position is the most stable position. Okay, we can see the center of gravity is less, the stability is more. See, the potential energy here it is in the minimum position. The less potential energy means it is in higher stable state. Why? Because the center of gravity, the height of center of gravity here, it is less among all the three configuration. So here we can see how the stability, okay, how the stability changes according to their position, to their height of center of gravity. We can see in this graph. So here it is the explanation of previous experiment. Okay. The equilibrium refer is nothing but refer to the state, means balance. Equilibrium means what? Equilibrium means in the all side the force is balanced. Okay, in let the C1, C2, C3, it is the three configuration, they are in equilibrium position, means what? There is no change in configuration, means there are no perturbation, no randomness, no disturbance, so they are in equilibrium position. Here the configuration C2 has the highest energy. The small perturbation of the system will take the downhill energy, means in C2, see, in C2 position it is the highest unstable state. Why? Because the height of center of gravity is more. Now the configuration C3 has the lowest point, lowest center of gravity, so it is the most stable state. Same, the metastable, first the A configuration it is called as metastable state, means it is not so highly stable, not so highly unstable. Okay, so three kinds of equilibrium is there with respect to their energy: stable state, metastable state, or unstable state. Okay, unstable state means the energy is maximum, stable state means the energy is minimum, reciprocal. Stability means the energy is less, unstable means the energy is more. The energy means here it is potential energy. Okay, so now we'll discuss about the laws of thermodynamics. There are four laws: zeroth law, first order, second law, third law. Okay, first the zeroth law of thermodynamics, what? It is nothing but it is the similar to the transitive property of your mathematics. Okay, if A is equilibrium with B and B is equilibrium with C, then A will be equilibrium with C. Here it is the same. Zeroth law states that if the two systems, let A and B, are equilibrium with each other. Equilibrium means no heat flows, no heat is gained or no heat is lost. If same, the B is equilibrium with C, then the A will be equilibrium with C. Now the second law is first law of thermodynamics. It is nothing but it explains about the conservation of energy. Let the system is there, one system is there, and we are feeding some heat. Okay, the heat is gained to the system. Then what will happen? The internal energy of that system will going to increase. So the system, what will do some work to compensate the energy. Okay, how much heat it is gained, it will compensate that energy in the form of work done. So here we are getting one equation, that is del U is equal to Q minus W. Here it is U is internal energy and Q is heat gain and W is work done. So for the small change, for the infinitesimal change, du we can write del Q minus del W. Here also we can write Q is equal to del U plus W. It is the first law of thermodynamics state, conservation of energy. How much heat it is gained to a system, it will compensate by doing some work and some internal energy. Now in the thermodynamics, sign of Q and W is matter, because it is in thermodynamic in numerical. Okay, in numerical it is most important to know the what will be the sign. Magnitude will be same, but the sign will be changed in terms of Q and W. If let the one system is there, if the system if gain some heat, then Q is positive. Okay, if it is gain some heat, then Q will be positive. Let the system loses some heat, let the system lose some heat, then Q, the sign of the Q will be negative. Sorry, here it is, will be negative. If the system loses some heat, then Q will be negative. Same for W, if the work done by the system, then W will be positive. If work done on the system, then W will be negative. Means here it is, it's saying about the sign, the magnitude will be same. Okay, how much heat is gained or lost, Q will be same. Let the system is the gain some heat, let 25 joule or 25 calorie. If the system gains heat, then it will be positive sign. If the system loses some heat, then it will be minus 25 joule. The magnitude will be same, only the sign will be changed. Now the second law of thermodynamics. What? The second law of thermodynamics, it says about the entropy. Okay, entropy is nothing but it is some randomness or some perturbation. If the system is going to some perturbation or some disturbance, then the entropy will be increased. Okay, so what about the second law of thermodynamics? All the natural process are spontaneous. Okay, spontaneous means there will be some disturbance or there will be some inorder. So the entropy of a system will be increases for the spontaneous or irreversible. Irreversible means some work done is going to happen, but the system will never change to its previous position. Reversible means it can be changed, but irreversible means it cannot be changed. Okay, the change will be for permanent. So the entropy is defined by the equation, that is del Q reversible by T. T here it is temperature, and del ds it is the function of state. Okay, entropy is the function. There is two function, like a function of state or path function, but here entropy will depend upon the state, means initial state in final state, not about the path. Okay, so the for the second law of thermodynamics, the entropy for the any spontaneous reaction of the natural process, the del S is negative, and the ds is defined by the equation, that is del Q reversible by T. Now the third law of thermodynamics says the entropy of the perfect crystal is 0 when the temperature of the crystal is at absolute 0 Kelvin. When for a perfect, let the perfect crystal is there, where the temperature is at 0 Kelvin, the entropy will be 0. Means the limiting del S at temperature 0 Kelvin, it will be 0. It is the fourth most important law of thermodynamics. Okay. Now, what is thermodynamic potential? Okay, we'll going to discuss, and how many parameters are there in terms of thermodynamic potential. One can be your internal energy, heat, or Gibbs free energy, or Helmholtz energy, and this is the parameters of thermodynamics. Okay, so the thermodynamic potential is nothing but it is a scalar potential to represent the thermodynamic state of the system. Okay, so now the thermodynamics potential, it can be four types, like one is internal energy, that is U, enthalpy, H, Gibbs free energy, or Helmholtz free energy. And there are state variables are there in thermodynamic parameters, like pressure, volume, temperature, okay, entropy. These are the state function. And the two terms we have to remember, one is intensive property, what is extensive property. Intensive property means which is the independent of size. Let the example is pressure and temperature, it will not depend upon the size of matter. Okay, so these two are intensive property. What is the extensive property? Extensive property means it will be directly depends upon the amount of matter. Okay, how the amount of matter is changing, it will be depend. So some example of extensive property is volume, energy, Gibbs free energy, Helmholtz energy, all the potential are going to depend on amount of matter. So now the heat capacity. Okay, the first parameter, thermodynamic parameter, we are going to discuss, that is heat capacity. First, what is the heat capacity? See, heat capacity from the definition it says is nothing but the amount of heat. Okay, the amount of heat needed or required to raise by an unit amount of substance to increase unit in temperature. The unit amount of substance can measured in grams or mole, and the unit in temperature means in degrees Celsius or Kelvin, the unit. Okay, nothing but the heat capacity, how much heat it will be required to increase the temperature of a 1 gram substance or 1 mole substance. So the heating means the addition of energy, it can be carried out at constant volume or constant pressure. So there are two heat capacity, one is CV and another one is CP. CV means the heat capacity at constant volume and CP means the heat capacity at constant pressure. And the thermodynamic equation also will get the CV is del E by del T at V, or we can write CV is del U by del T at constant volume, and the thermodynamic equation CP is del H by del T at constant pressure. In further classes, we will going to derive how the CV is del U by del T and how the CP is del H by del T. So the heat capacity also, it is an extensive property because it depends on the amount of matter. Okay. So if the substance has more heat capacity means more heat is required to increase the temperature. So the heat capacity of water is more than the air. It is the CP of water is 29.07 joule per Kelvin per mole, and another one, the unit of heat capacity is joule per Kelvin per mole. Okay, or joule per degree Celsius per mole we can write. So the CP of water is high than the air. So the that implies the oceans or the water will heat up slowly as compared to air. Okay, because the heat capacity of water is more than the air. So the heat, water, for the heating, the water will be required more temperature than the air. Okay, that is, it is telling that the implies the ocean will heat up slowly as compared to the atmosphere. So in the next class, we'll going to discuss about the another parameter, that is internal energy. Okay, and how the relation about the how it is heat capacity will what relation about in between the heat capacity, internal energy, entropy, the different type of like parameters are there. We'll going to discuss in the next class. Thank you so much.